In the last class, we have discussed the four chemical characteristics, that is pH, chloride, then we have discussed on hardness and the DO, that is dissolved oxygen. In today's class, we are going to discuss on the importance of sulfates, its desirable and permissible limit, what happens if it is going to exceed this particular limit, okay, and what kind of odor or taste, how it is going to be affected if the more amount of sulfates are there in water, that we are going to discuss. Then how the nitrates will be inculcated in water, that we are going to discuss, along with its desirable permissible limits, along with its effect. Then we are going to see on iron along with its desirable and permissible limit, then how to detect this iron, then fluoride, what the importance of a fluoride along with its desirable and permissible limits. Okay, so first then directly we are going to start with the sulfates. Sulfate ion is one of the major anion occurring in the natural waters. Okay, now rainwater has quite high concentration of sulfate, particularly in the areas with a high atmospheric pollution. Okay, now why the rainwater will be having the high concentration of sulfate is, now when the precipitate is going to occur, right, when the precipitate is going to occur, right, now if the area here there is some land, from here too much amount of industries and too much amount of vehicles are there in the this particular area, right, these will be giving more amount of smoke. So this smoke will be having carbon monoxide, dioxide, along with the oxides of sulfur, that we generally call it as a SOx, that is oxides of sulfur, then NOx. Okay, this more amount of the rainwater will be having more amount of sulfate. Why is, when the precipitate is coming from the clouds, right, now the here from the smokes is going to come, the smoke is going to come from the highly polluted areas. Now these water droplets are going to absorb the oxides of sulfur with it, and when it ultimately it reaches ground, right, these particular rain droplets will be having the absorbed amount of oxides of sulfur in it. So when it reaches the ground surface, it will be enriched with more amount of the sulfates in it. So that is how the rainwater will be having more amount of sulfates in it. Okay, it is present in various mineral salts that are found in soil, that is the soil will also will be having the some amount of sulfates in it. The sulfate forms salts with a variety of elements including barium, calcium, magnesium, potassium and sodium. Okay, the sulfate may be leached from the soil. Okay, when it is going to come from the ground, okay, it may be the this particular soil will be having the sulfate, and it may be get leached out into the soil. Okay, and magnesium and potassium and sodium sulfate salts are soluble in water. Okay, now decaying plant and animal matter may also release some amount of sulfate into water. That means if any amount of if we are having any kind of a water body, okay, here if any decayed plants are there, or if any death of a particular animal has happened in this particular water body, then it will increase the sulfate content. Due to the decaying, it will increase the sulfate content into the water. Okay, now the human activities such as combustion of fuels and the sour gas process releasing sulfur oxides to the atmosphere, some of which is converted into the sulfate. That means we are going to burn the fossil fuels and all, it also releases the sulfur oxides to the atmosphere. Okay, sulfate is generally considered to be non-toxic. The consumption of drinking water containing the high amount of magnesium or sodium sulfate may result in intestinal discomfort, diarrhea, and consequently dehydration. Okay, the effect is observed when someone drinks water which contains more than 500 mg per liter. Over time, the individuals appear to develop a tolerance to high concentration of sulfate. Okay, it is not advisable to use the water which is contains the high amount of sulfates to the infants. Okay, now this high amount of sulfate will also induce an offensive taste to the water. Okay, now it is going to induce the offensive taste when it is in the range from 250 mg to 1000 mg per liter. Okay, now high concentration of sulfate may interference in the efficiency of the chlorination of the some water supplies. Also, sulfate salts may increase the corrosive property of water. Our IS code suggests that the sulfate should be in the range of 200 mg per liter, that is the desirable limit, and permissible limit is they have given, that is 400 mg per liter. Okay, next parameter is we are going to have is nitrate. Nitrate ion is a polyatomic ion with having the empirical formula NO3 minus. Okay, now nitrogenous matter is present in domestic sewage, fertilizer factory effluents, and agricultural runoff water, and many industries and solid waste leachates. Okay, the large inputs of nitrogen to surface and subsurface water may result in excess growth of algae and the aquatic weeds. That means the presence of aquatic algae or weeds, that shows the presence of the stagnant water, the presence of algae and the presence of weeds. It shows that the more amount of nitrogen content is there in that particular water. Okay, now moreover, a build of nitrate is drinking water supplies is thought to pose a health hazard to human, particularly infants, okay, as a livestock. Okay, major forms of nitrogen in water and wastewater are present in the form of ammonical nitrogen, then organic nitrogen, nitrite, nitrate, nitrous oxide, and molecular nitrogen. As per BIS limit, our BIS limit suggests that the desirable limit for this particular nitrate should be below 45 mg per liter, and permissible limit they have given is the 100 mg per liter. Beyond this limit, it will cause the methemoglobinemia or blue baby disease in infants. Okay, infants in particularly are especially vulnerable to this particular blue baby disease, in which the nitrate metabolizing triglycerides present in high concentration than at any other stage of development. Okay, now this blue baby disease is a disorder characterized by the presence of higher than normal level of the methemoglobin in the blood. Signs and symptoms of this particular blue baby disease includes the shortness of breath, then cyanosis, and then mental status changes, headache, fatigue, then exercise intolerance, dizziness, and loss of consciousness. Severe methemoglobin, right, patients have the seizures, and baby may go under a coma and may die. Nitrate concentration can be detected by using the UV visible spectrophotometer, and the limit should be less than 45 mg per liter. Iron is one of the earth's most plentiful resources, making up to at least 5% of the earth crust. Rainfall seeping through this particular soil, right, when the rainfall is going to seep, right, when it is going to seep, it is this particular soil, if it is going to have the iron content in the soil, then it will percolate through the soil and it will be entering into the groundwater. Normally, this lateritic area, in the lateritic soil area or lateritic rocks wherever are there, we will be getting the more iron content in the wells. Okay, iron is generally divided into two main types, that is, one type is soluble type and the other is insoluble type. Okay, the iron is the most common. This particular soluble type of iron is most common form and one that creates the most complaints by water. This type of iron is identified by after pouring a glass of cold clear water. If followed to stand for a few minutes, it is going to give the brown particles will appear in the glass. Eventually it is going to get settled down at bottom. Okay, now next type is the insoluble type. Okay, now if we take how the insoluble type will be having is, right, if we take a glass of water, right, which is going to have the red water, it is due to the normally it is due to the presence of iron. It appears rusty or has a red or yellow color. Although it is not going to be very common in water, insoluble iron can create a serious taste and appearance problem for water. Iron exists along with a certain kind of a bacteria problem can become a worse. Now if in a well water, in a water, if the bacteria of iron are there, then it is going to create too much problem. Okay, iron bacteria consumes the iron to survive and leave a reddish brown or yellowish slime and clog plumbing and cause offensive odor. It creates an offensive odor. Okay, next is iron is not considered hazardous to health. In fact, it is going to be good for health and it transmits the oxygen to our blood. Okay, the presence of iron in natural waters can be attributed to due to the rocks and minerals. If the rocks and minerals are there, then it will be having more amount of the iron content that is going to leachate into the groundwater. Okay, the permissible limit for drinking water of iron is 0.3. Our IS code suggests that we should have around 0.3 mg per liter of iron, and it more than 0.3 mg per liter in the iron, it causes the stains in the steel containers. They also form red spots on cloth and white paper. Okay, now this particular iron can be detected by again using the UV visible spectrophotometer. Now the treatment considered for the treatments, what different kinds of a treatment in order to remove this iron are the aeration we can use filtration, then we can use the water softener. In this particularly we are going to use the ion exchange, then ozonization, then chlorination, chemical oxidizer used to convert the soluble iron to insoluble iron form. So your iron content should be 0.3 mg per liter. Fluoride is a geochemical contaminant that usually we are going to get the natural water source also, and we are going to get it in the well water also. Now, how we have talked already regarding the during the miscellaneous treatment, we have talked more about the fluoride, right? What kind of a problems it is having, how it is going to help us, and then all those things we have already discussed, but we will cover some more points regarding the fluoride. Generally, it is associated in natural few amount of sedimentary rocks or igneous rocks. Fluoride seldom found in appreciable quantities in the surface water as well as the groundwater. The fluoride is essential for normal mineralization of bones and formation of dental enamel. Okay, it is going to help in the development of bone and teeth. Okay, the desirable limit of fluoride in drinking water is 1 mg per liter. If fluoride is less than 1 mg per liter, we have already discussed that it is going to cause the dental caries, that is the formation of weaker tooth enamel leading to early tooth decay in children aged between 1 to 14. In such cases, fluoride has to be added in the form of the sodium fluoride, that is nothing but we call it as an fluoridation. Okay, if a fluoride concentration is more than 1 mg per liter, especially if it is more than 1.5 mg per liter, then it is going to have the discoloration of teeth. Okay, now in mild dental fluorosis, affected tooth lose luster and show chalkiness. Okay, and in course of time the tooth will appear yellow and it is normally it will be turning to the dark brown color. Okay, next is if the fluoride content in water, if it is going to be more than your 5 mg per liter, if it is crossing more than 5 mg per liter, then we are going to have the skeletal fluorosis, that is the abnormal growth of bones is going to occur when the fluoride content is more than 5 mg per liter. We call it as an skeletal fluorosis. Okay, this regarding this we can determine the fluoride content by the process called as the Alzerine visual comparison method. We can determine how much the amount of fluoride is present in the water. Now we are going to discuss one more parameter called as an biochemical oxygen demand. Okay, we are going to discuss one more parameter, that is the biochemical oxygen demand, which is not exactly the water characteristics, but it comes in the wastewater characteristics. That is an extra thing what we are going to cover in the water characteristics. Actually, it is a wastewater characteristic. It is not considered as a drinking water parameter. Now, what is this BOD? BOD is nothing but the biochemical oxygen demand. Now, how it is going to be important to learn and why it is important, I will tell you. It is mainly a characteristics of wastewater, not a drinking water parameter. Now, it can be defined as it is the amount of oxygen required in order to decompose the organic matter in presence of oxygen at a standard temperature. It is usually required by the microbes. Now, we will define it once again in order to remember it. Biochemical oxygen demand is nothing but it is an amount of oxygen required by the microbes in order to decompose the organic matter present in it at a standard temperature and pressure. Okay. Now, we as a human being, how we survive on this particular earth is we are going to consume oxygen, we are going to consume food, and whatever the food we are going to consume, we are going to have we are going to digest it by our having the day-to-day activities and by consuming oxygen and all. So both the intake and outgoing of the energy will be there. So likewise, now if we take a glass of water, okay, suppose here this particular water is going to have some organic matter in it. Now, organic matter, when it is there in water, this is nothing but the organic matter. If it is there in a water, right, what will happen to this particular organic matter? It starts to decompose. Now, how it is going to decompose? There will be some amount of microbes, right? There are some amount of microbes which are going to act on these particular organic matter and it starts to decompose. Now, the question is how these microbes is going to survive? Like how we survive by consuming oxygen, similarly, these microbes are going to survive in water by consuming the oxygen which is present in this particular water, that we call it as an DO. Yesterday's class we have discussed regarding DO, the oxygen which is present in the dissolved form in water, we call it as an DO. So similarly, here also in this particular water also, though organic matter is there, the oxygen content will be there. Okay, now as the time passes, this DO content it goes on reducing. Why it goes on reducing is the microbes are going to consume this amount of DO which is there in this particular water. Okay, so as time passes, what is going to happen? The DO is going to reduce. That means this particular water is going to have some dissolved oxygen in it. As time passes, the DO is going to reduce. Why it going to reduce? The microbes are going to consume it. Now, what is BOD? As I have defined, BOD is nothing but it is an amount of oxygen required by the microbes in order to decompose the organic matter at a standard temperature and pressure. So, they will start to decompose. How they will start to decompose? By consuming the oxygen. So, what is going to happen here? The BOD is going to increase. So, this DO and BOD is going to have the relation, right? As DO is getting reduced, this BOD is going to increase. Okay. Now, this particular BOD is actually a wastewater parameter, it is also going to have some relation with the temperature. Okay, regarding the relation with BOD is having some relation with the temperature, that we are going to study in detail in the next semester. But right now you need to remember that what is a BOD is. BOD is nothing but a wastewater parameter, right? It is not a drinking water parameter. But if now I have told the BOD DO in what range it will be there, 4 to 8 mg per liter. Now if this DO, if it is going to reduce to 2 mg per liter from 4 to 8 mg per liter, if it is showing that it is having the 2 mg per liter, that it means that this particular water with having the 4 to 8 mg per liter of amount of DO will be short it is going to have the contamination. Why is it should be there in between, the DO should be there in that particular water in between 4 to 8 mg per liter. It shows that this particular water is surely contaminated, because why the DO reduction is there. Now here the DO reduction is there means here BOD has increased. So when BOD is there, it is surely indicates that some of all amount of microbes are there in the water. And for a drinking water, there should not have any amount of BOD should be there, right? If BOD is there, then it shows that it is an contaminated water. Okay, it is, if BOD is there, it shows that contaminated water. So BOD should not be there for a drinking water. Okay, it should not be there in the drinking water. So regarding this, the BOD we will be studying in detail when you come or when you are going to learn regarding wastewater treatment. The BOD, the entire wastewater will be dependent upon this particular BOD. Okay, so BOD is going to have more weightage in wastewater. Okay, now in today's class we have covered the chemical characteristics such as sulfates, nitrates, iron, fluoride, and BOD is actually a wastewater parameter, but I have given some overview on this particular BOD. Okay, now we have also seen what are the importance of these sulfates, nitrates, iron and fluoride, and what should be its limit, what happens if it is going to exceed the limit. All these things we have discussed in today's class. In tomorrow's class we are going to discuss regarding the biological characteristics. What are the different biological characteristics that water is going to have. Now whatever the physical and chemical characteristics we have discussed along with its desirable and permissible limit. Now in examination they may ask you find out or explain regarding the sulfates along with its desirable and permissible limit, or directly they may ask what are the IS standard limit or BIS standard limits for the XYZ kind of an element, that is sulfate, nitrate. These are the chemical ones. Physical also they may ask for color, then odor, or they may also ask regarding that. Then in tomorrow's class we are going to see regarding the biological characteristics.